Welcome all of you to SST College of Arts and Commerce. This is SST Edupedia. Myself Krishna Salgaonkar. I am an assistant professor in IT and CS department. Today we are going to talk about computer graphics and animation, which is a course of semester 4 SYCS. And the topic of discussion is 2D transformation. Let's start with the topic. First, we will understand what is meant by 2D transformations or what are 2D transformations. Transformation means changing some graphic into something else by applying rules. Means you have to change a graphic into something else by applying some rules. When a transformation takes place on a 2D plane, it is called 2D transformation. If you are using, if the transformation is taking place on a 2D plane, that is a plane with X and Y axis, then it is called as a 2D transformation. Transformation plays an important role in computer graphics to reposition the graphic on the screen and change their size or orientation. So basically what a transformation does, so it changes the position of the graphics or it changes their size or orientations. Okay. Next is what are the different types of 2D transformation. 2D basically transformation is 2D transformation or 3D transformation. Here we are talking about 2D transformations, and the types are translation, rotation, scaling, reflection, shearing. These are the main types. Out of this, we are going to discuss a few basic transformation. They are translation, rotation, shearing and scaling. So let's start with first translation. First, we will try to understand what is meant by translation. A translation moves an object to a different position on the screen. You can translate a point in a 2D by adding translated coordinates tx, ty to the original coordinate xy to get the new coordinate. What it means? See, basically translation means we have to move an object from one place to another place. How we are going to do that? So we need two factors, that is tx and ty, which will move that object in x position as well as in y position. We are going to add these two objects or these two coordinates in the actual coordinates, that is starting coordinates, and we get some new coordinates. For understanding it better, see this thing. My original point is at pxy and it moves from pxy to the new position p dash, which is x dash and y dash. So how this is happening? So if you see, I have written over here x dash is equal to x plus tx. Tx is the factor with which the translation is occurring. Y dash is equal to y plus ty. So in a matrix format, it will be like this: x dash, y dash and 1. And this is the unit matrix: 1 0 tx, 0 1 ty and 0 0 1. We are going to add this in the original xy position. So when we add this, we get the new x dash and y dash. Now let's move to the next transformation. This transformation is called as rotation. So we are moving the particular object by an angle theta. In rotation, we rotate the object at a particular angle theta from its origin. From the figure is on the next page. We can see that the point pxy is located at an angle phi from the horizontal x coordinate with the distance r from the origin. So let's see the diagram. See, there is a point p xy. The xy coordinates are there, that the point p, and we are moving it to the new position x dash y dash. Here angle theta is the rotation angle. So we are actually rotating the point from its origin to the new location. Here we have to use some formula. So initially x is equal to r cos theta. Now see in the diagram, you can find out the r. Okay. Now that r is if I want cos theta is equal to r upon x, and if we calculate, then we get x is equal to r cos phi. Then y is equal to r sin phi. Okay. Now this phi we calculate in terms of theta. So actually if you see that whole angle from the base, it is theta plus phi. So x dash is equal to r cos phi plus theta and y dash is equal to r sin phi plus theta. When we solve, we get x dash is equal to x cos theta minus y sin theta and y dash is equal to x sin theta plus y cos theta. Now we can represent this thing in a matrix format. So when you are going to multiply the coordinates with this matrix, you get the new coordinates, which will be the rotational points. So this way, a 2D transformation of rotation, 2D transformation, but type is rotation happens. Next is shearing. So what is mean by shearing? I will just show you this diagram. This is called as shearing. The original shape is a rectangular box, and you can see in the next diagram it is sheared. Okay. Now we will first see what is mean by a shearing. Transformation that slant the shape of an object is called the shear transformation. There are two shear, transformation x shear and transformation y shear. One shift x coordinate values and other shift y coordinate values. So if you are doing transformation x shear, it shifts x coordinate values, and if you are doing transformation y shear, it shifts y coordinate values. However, in both the cases, only one coordinate changes its coordinate and other preserve its values. So if you are changing x, then x will change, y will remain as it is, and if you are changing y, y will change and x will remain as it is. Shearing is also termed as skewing. Shearing is also known as skewing. So this is the diagram for shearing. Now SHX, this is the shearing factor, is equal to Px plus HPy, and SHY is equal to Py. So this x direction shear, if I want to calculate, then that SHX, that I have to use in the second row, and if it is in y direction, then SHY I have to use in the second column. So there I will write that shear values, and when I multiply this matrix with the original x and y positions, then we get some new points. This is about shearing. Now after shearing, there is scaling. Scaling means if it is a small object, or we have an object of 2 by 2, we can scale it to 4 by 4. Okay. Now to change the size of an object, scaling transformation is used. In the scaling process, you either expand or compress the dimension of the object. So there are two things, either you are going to expand the object or you are going to compress the object. Scaling can be achieved by multiplying the original coordinates of the object with the scaling factor to get the desired results. So how we are going to do the scaling? We are going to multiply the scaling factor with the original coordinates. Now let's see the things. So this is the scaling. So my scaling factor Sx and Sy I consider as 1.5. So if I expand it, I use 1.5, and if I reduce it, okay, then I use 0.5. So that way my shape, which is in the center, is either expanding or getting reduced. This is called as scaling. Now my new coordinate x dash is equal to x into Sx and y dash is equal to y into here my x dash is equal to x into Sx and my y dash is equal to y into Sy. Now this is my scaling matrix Sx 0 0 0 Sy 0 and 0 0 1. This matrix, when I am going to multiply with my original values, I get some new values, and that will be the scale that I can use for scaling a particular object. Now let's revise the thing. So actually here we understand what is mean by 2D translation. There are basic 4 types of translations, that is translation, then rotation, then shearing and scaling. That's all for today. Thank you everyone.